This section we're going to talk about property of logarithms. So property of logarithm, we need to remember that when you have 1 on the larger base of the log, it will be always equals to 0. When small base, larger base have the same value, it will be equals to 1. Small base and larger base same and have exponents, then that exponent will be the solution. Also that if log is on the exponent of the value, and that value is same as the small base of that logarithm, then larger base become a solution of that. The fifth one is when you have multiplication of larger base, that too multiplication can be separated into addition of two different logarithms with the same small base. If it's a larger base have the value of the divisions, then the numerator subtract by denominator can be separated into two logarithm functions. If you have a logarithm with small base, larger base, different number, right? And then you have exponents to the larger base, that exponent can be same as multiplication to that logarithm functions. So the other ones, 4, I believe you probably seen it before, or you can just change it to exponential to make sure they're true, right? But this 3 right here is going to be something different you can use to either these directions, make it smaller, one term of logarithm if you have several terms, by using if addition become multiplication, subtraction become divisions, right? Or this direction will be stretching out, right? Logarithm stretching out. Usually when you're solving problem, it will be shrinking into one logarithm. You also have change of base formulas. So if you have a log b to the x exponents, this is going to be same as using the same small base a and a. You should be able to separate this out into numerator. Larger base goes to the numerator, smaller base goes into denominator. And usually we can use this to figure out some value using calculator, because calculator do have log 10 and ln functions, right? If you end up getting something like, let me see, if you end up getting something like log 2, 5, right? Then you should be able to change it to log 10, 5 over log 10, 2 to able to find your answer using the calculator. Because calculator log 2, 5, you cannot get that value because you do not have log 2 on your calculator, right? But you do have log 10 and ln function, which is log e, right? And that's another thing that we went over before. So make sure log 10 is same thing as if you just see log without the small base. Log e is same as the ln function. So using that property, let's see if we can, example 1, trying to extend, right? So this is multiplication right here, 8 times x. So let's see if we can expand this. So this is going to be same as log 2, 8 plus log 2x. But then also we know that 8 is same as 2 cube. And if we have same small and larger base, that's same as the exponent. So this is same as 3. So using all those properties, you should be able to extend this logarithm into this. What about the next one? You have 3 multiplications. So you can extend into 3 terms by using additions. What about going the other way? Well, what about if you have a divisions, right? But we'll do going the other way in the other example. So division, we can use it subtractions, right? So numerator minus denominator. So that will be that, right? What about this one? This is going to be log 10, right? If you don't have any base, small base, and this is going to be log 1000. We know just this is same as log 10 cube. So same small base, larger base, this must be same as just 3, right? Example 3 is asking you to apply the power property of logarithm. So this length function, if I just change fifth roots to the power, it will be, you already have squares, so it will be over 5, right? So that exponents, we should be able to change it to multiplications to that length function. Same thing, this one, the exponent, right? Your exponent is same thing as multiplication to that logarithm functions. The next one is trying to see if we can use multiplication, divisions, and exponent all together, but expanding, right? So this one, when I expand first, I see this is division, so I will first look for subtractions. Right? And then I see that cube is same as multiplying. At the same time, I see multiplication right here, so I should be able to expand that into addition. And if you wanted to get rid of, you need to make sure you distribute this negative. So this will become subtraction also. And you should be able to make multiplication with that exponent. And that's how you can expand the given expression. Let's try another one. This one, I will get rid of the roots first because that blocks my divisions, right? So let's get rid of the cube roots into the power. That will give you x plus y to third exponent over 10 to the 1/3 exponent. So now numerator denominator is not in one group, I can separate that with subtractions. Then that exponents, I can bring it in front of logarithm to make multiplications. And we know log 10. Let's get rid of log 10. This small base is 10. So small base, larger base, same means 1, right? So let me erase that. And times 1, right? Which is going to be 1/3. What about if we're looking at example 5 going the other way? So we're not expanding, we're shrinking, right? Trying to make it into single logarithms. So then this is going to be, this subtraction means the log that followed by subtractions is going to be on denominator, right? So it will be log 2. Only the positive will be on the numerator. The denominator will be all subtraction logarithms. You can also tell, let me bring this to the side. And when you factor that negative, you get log 2 7 plus log 2 5. So you can tell this is multiplications, but the whole thing is subtractions, right? So that's why this is multiplication. Okay, so when I finish that problem off, this will give you log 2 reduce, look like 5 goes into 560, 112 times. 7 goes into that number 16 times. And we know that 16 is equals to, oops, let me rewrite that. 2 to the 4th power, so that will be equals to 4. I tried to reduce or make a single logarithm and end up finding the solutions. Let's look at another one. So this one, when you have multiplications, you should be able to bring it into the power, right? So that's going to be 1/2 power. This is going to be another 1/2 power, right? And what's 1/2 power mean? That's square root. And because we can factor, that's cube, negative, then this makes it log square root of b plus log square root of c. That's the one inside our parenthesis will become denominator, right? So on the numerator will be just a cube. Denominator will be square root of b and square root of c. And you should be able to put it all together. So it will be square root of bc. And that's how you can make a single logarithm on that problem. If we try one more time, let's do make it exponent. 1/2 becomes square root of x then, right? Plus ln x squared minus 1 minus ln x plus 1. Because this is positive, this is going to become multiplication. This is negative ln, that will be on denominator. So when you rewrite this into the single logarithm, natural logarithm, it will be square root of x times x squared minus 1 all over x plus 1. I can reduce these fractions because we know that x squared minus 1 is same as x minus 1 times x plus 1. And denominator, you have x plus 1. So these two can be canceled out. So when you make it simpler into single logarithm, but simple form, this is what you have remains. This is all you have remains. Next example we're looking at, this is the one that I mentioned. You can use calculator to find the solutions, right? So as it is, you cannot find exact value using calculator because you do not have log 5, right? But then you can change this into either log 10 140 over log 10 5 or ln 140 over ln 5. You should be end up getting either way same answer, 3.07. That's the value you can find on the calculator. If you can convert this into one of this, then you should be able to using calculator to find the exact value like that. So that means the next one, if we wanted to use the calculator, I should be able to convert this into ln 17 over ln 6, right? So try this on your calculator and see what you get, right? It should be 1.58. Since we went over all the property at this point with the exponential property, next section we're going to talk about solving. We're going to learn how to solve logarithm and exponential equations.